All right, welcome to The Explainer. Today we're digging into Elon Musk's absolutely wild plan to solve what he thinks is AI's single biggest hidden problem. And yeah, you probably guessed it, it involves a ton of rockets.
So let's just jump right in. What do you think is the biggest thing holding AI back right now? Is it the code, the chips, getting enough data? Well, Musk says it's none of those. He thinks it's something way more basic. And it's probably not what you'd expect.
See, the real wall we're about to slam into, it's not in the software. It has nothing to do with code. It's a physical problem, a problem of atoms, not bits. We're talking about actual physical stuff. And Musk has a pretty blunt way of putting it. He says all the folks in software land are about to get a really hard lesson in hardware. This is the kind of problem you just can't code your way out of. Okay, so here's the fundamental problem. Imagine a car that's getting exponentially faster every single year. But the amount of gas available in the world, it's staying exactly the same. That's what's happening with AI. The demand for compute is just exploding, but our ability to actually power all those chips is basically flatlining. And Musk backs this up with some pretty stark data. If you take China out of the equation, global electricity output is barely growing at all. It's flat. So we're trying to stack this insane exponential growth of AI on top of a power grid that's not going anywhere. You can see how that's just not going to work. Something's got to break. And get this, the power problem is way worse than it looks on the surface. It's not just about turning on the GPUs. You've got all the networking gear, the storage. Then you have to plan for cooling on the hottest day of the summer, which can add like 40% more power. Oh, and you need a safety margin, right? For when things go wrong. That's another 20–25%. All of a sudden, the amount of electricity you need to pull from the grid is way more than what the chips themselves are actually using. So Musk asks this really simple question, right? How are you going to turn the chips on? Magical power sources? Magical electricity fairies? I mean, his point is that the hardware is stacking up, but the power just isn't there. And you can't just snap your fingers and get more. We're talking about real-world stuff here, like gas turbines being sold out for years and utility companies that take forever to build anything. You can't just wish this problem away. Okay, so if building more power plants on Earth is just this nightmare of red tape, backlogs, and hard physical limits, what's the alternative? Where do you go? Well, if you're Elon Musk, the answer is pretty simple. You don't build out, you build up. And the reason why is actually shockingly simple. It's just always sunny in space. Think about it. Down here on Earth, we're constantly fighting against nighttime, clouds, bad weather, even the seasons. The atmosphere itself blocks a ton of energy. But in space, none of that matters. You get pure, uninterrupted, 24/7 sunshine.
Now, this is where the idea goes from just interesting to completely mind-blowing, because Musk isn't just saying this is possible. He's arguing that very soon, putting these massive AI systems in space will be by far the cheapest way to do it. Cheaper than building on Earth.
Just look at all the energy we waste down here. Right off the bat, the atmosphere filters out about 30% of the sun's power. Then, obviously, half the time it's night. So there goes another 50%. And that's before you even factor in clouds or winter. In orbit, you just don't have any of those problems. You get 100% of the power 100% of the time. So what's the bottom line? Well, you take the exact same solar panel, put one on the ground and one in orbit, and the one in space will generate about 5 times more electricity over the course of a year. 5 times, all because there's no night, no clouds, no atmosphere getting in the way. But wait, it gets even better. Because on Earth, if you want solar power 24/7, you need giant, incredibly expensive batteries to store power for the night. In space, since the sun never sets, you don't need any of that. And when you take away the massive cost of batteries, Musk figures the cost advantage actually jumps to 10 times. A 10x improvement. And I really want to stress this point. This isn't some far-off sci-fi dream for our grandkids. Musk is putting a real timeline on this, a super aggressive one. He's predicting that in 36 months, or even less, it will be cheaper to put AI in space than on Earth. That's really soon. Okay, so the economics make sense. But how do you actually do it? To make this happen, you have to launch a truly insane amount of stuff into orbit. The scale we're talking about is, well, it's hard to even wrap your head around.
Musk's number is 10,000 10,000. That's 10,000 Starship launches per year. Just to get all the solar panels, the cooling systems, the computers, all of it into orbit. Let's just let that sink in for a second. That's more than one launch every single hour of every single day, all year long. It's a constant conveyor belt to space.
And the goal here is to be launching hundreds of gigawatts of AI processing power every single year, starting in about 5 years. Now, to give you some sense of what that means, Musk says that a terawatt of AI, which is the next step up, would use up twice the electricity of the entire United States. The ambition here isn't just big, it's planetary in scale. But you know how it goes, right? It's like a game of whack-a-mole. You solve one huge problem and another one just pops right up. So once you solve the energy problem by going to space, you suddenly create a whole new set of bottlenecks right back here on the ground.
So the bottleneck just keeps shifting. Right now it's power on Earth. Okay, you solve that with solar and space. Great. Now your new bottleneck is launch capacity. Fine, you solve that with an insane number of Starship launches, but what's next? Well, now you have to actually make all the chips and all the memory you need to launch, and that becomes the final wall.
And of course, Musk has a name for the solution. You know, we've all heard of gigafactories for batteries. Well, to build all these chips, he says we're going to need terafabs. That's the next level up. Factories that can churn out computer hardware on a scale that just doesn't even exist today. So you might be thinking, this is all just a massive, ambitious engineering project. And it is. But for Musk, it's also about something much, much bigger. It's actually tied into a really deep philosophical mission about the future of, well, consciousness itself. He uses this phrase, the light cone of consciousness. The idea is that the ultimate goal here isn't just to make better AI so we can have better chatbots. The real mission is to make sure that consciousness, whether it's ours or the AI's, doesn't just die out here on Earth. It's about ensuring that flicker of intelligence spreads out into the universe and survives for the long term.
And really, that leaves us with a pretty huge question to think about, doesn't it? As we build all of this incredible system to power the next phase of intelligence, what kind of future are we actually building? When we send that light cone of consciousness out to the stars, what is it going to be? Is it going to be us? Is it going to be AI? Or is it going to be something else entirely? Something we can't even imagine yet?